Thanks everyone for joining my workshop today. My name is Sangit Patel. I'm a solutions engineer at Sauce Labs. I've actually been in the API testing industry for 5 or so years now at a couple different companies, and I've also been doing API development for many, many years before that. And so really my workshop today is going to be focused on, and again, this is the marketing title that was put together by my team, and it's scaling OpenAPI specs for contract testing and functional API testing of microservices. And so really what that means is the OpenAPI spec file is a very powerful spec file, and it can be used to do a number of things. And what we've done with it is use it to power a lot of our API testing. And so I have an example here of a very basic OpenAPI spec, and there's a couple things that I want to point out here that really do add to the powerfulness of this type of spec file. And so the first thing is you can add things like example files, you can add extensions and point out like a JSON here, and I can actually, as part of my spec, say, here's my URL example, but also when I get down to my components, I can actually point it to my specific JSON file, and it can grab an example from there when I need examples passed back. Now, a couple things that we've done is actually add extensions, which if you weren't aware, OpenAPI does allow you to add extensions into it, and these extensions are really awesome because what you can do and what we've done is add this, right? We've added a couple. One of the ones we've added here is the xSauce cond, and this is basically a field that we use as part of our tool, and so everything inside of here gets parsed out by our tool and gets used for a purpose, but any other tool that you would import this spec file into will completely ignore it. It's not going to break it, it's not going to cause any errors or warnings, it's just going to ignore it. It's going to say, hey, this is not something that I recognize or care about, and I'm going to ignore it. But our tool is going to be able to take that and use all of that data set to do additional things, right? And so another one of those is, if I go down into here, is the xSauce faker. And so we've added a library that lets you generate fake random data. In this case, I want it to generate an email address and a randomized email address every time I request or every time I call this API. And that'll come into play when we talk about mocking, which is one of the first things that I'm going to talk about. So let's actually jump over into that. So we have a tool called Pystry. It is a tiny containerized tool that is purely powered by the OpenAPI spec file. And so I can do things like mock out APIs with it. And it's really simple to do. I will call this command here, and all I'm really doing is running this tiny container. I'm mounting a directory where I have my spec files. I'm providing a port and all of that. And then I'm doing a few things in the back end here that'll come into play a little bit later on in this workshop, but I'm going to call it all at once right now. And so the one thing I am doing is passing in that spec file that we saw earlier, and that is the main driver. What our tool is going to do is parse that spec and automatically generate a bunch of mocked endpoints based on the definition of that spec file. I do have a logger functionality. What that's really going to do is it connects back into our cloud platform where it can send data and send results. And really, the last piece here, validate request, is part of the contract testing that we do. And so we've actually implemented contract testing purely based on the OpenAPI. So where the OpenAPI becomes your contract, it's your rule set of how your API should work. And we're actually utilizing that to do automated testing against the contract. And so if I go ahead and run this, what my tool is going to do is it's going to parse through and automatically create a bunch of mocked endpoints based on that specification file that we provided earlier. And so now I have a bunch of endpoints that I can call, and I can do something like this, where I can just make a, and maybe let me just pull this up a little bit bigger. I can call an API request to my localhost, to the port that I've assigned it, to the endpoint that I want. In this case, it is my release notes endpoint. And my release notes endpoint requires a version number to give me my release notes back. And so if I call this endpoint, we're actually going to see that it comes back with a response. This is just all to my local host. I can actually deploy this onto a server somewhere and make this available to be used by many applications, by anybody else that needs to use it. But for the purposes of this, I'm just running it on localhost, right? You can actually see that faker condition that we passed in earlier is generating a random email address for me. If I actually call this again, it's going to randomly generate a different email address. Very useful for when you want to, when using mocked endpoints, have some real data set back, right? If you're just getting a bunch of garbage back, like I have in text, not super useful if you're testing or if you want to build out something calling a mock on the back end, right? So having the ability to generate real data or even tie it to actual data is very important. And so one of the biggest things that this we utilize the OpenAPI spec to do is actually create mocked endpoints. I don't know if any of you out here have done API mocking. It's not the easiest of things to do if you have to set everything up yourself. It's sort of a nightmare. When we utilize the OpenAPI spec, it takes away a lot of the setup work, right? Because we're saying, here's my spec, just create the mocks based on what I've already done a bunch of work on when I created my spec file. And so we have that. We have the mocking side of things, and that comes into play for numerous use cases. Like a lot of what I've seen folks do is early on testing, right? You've got your spec file built out. You don't necessarily have the actual APIs created and loaded and running somewhere. And what you can actually do is create mocks and start testing against it. Start building out your repertoire of tests so that when you do have your APIs ready, it's a matter of swapping the URLs and being much farther ahead. We've seen folks replace dependencies, right? Third-party endpoints that you need to call as part of your application, and you don't want to use that, or you want to have a little bit more control against it. Having mocked endpoints is really useful for that. Now, a couple things that we also have the ability to do is contract test against that, right? We talked about that a little bit. And so contract testing has two sides to it. A consumer-side contract test and a producer-side contract test. So what I can do right now is my consumer side of it. And you can do an end-to-end where you would test both sides of it. I'm going to show you how each side works individually. And so in this case, I'm going to do my consumer side test. And what I'm going to actually do here is make this request to this endpoint again. And I know that my endpoint requires a version parameter. And I know that my spec, or the way I've created my spec, is that that version should be an integer. And if it's not an integer, it shouldn't work. And so if I actually pass in a string here and make this request again, it's actually going to return this, instead of just an error to me, it's going to return a contract validation. So it's actually going to say, okay, I saw the request that you made. I noticed that the query parameter version, you provided a string hello. And the schema defines it as the integer type. And so your validation failed. And because I have when I started this up, we passed in that -- validate request, which is going to validate all of my request parameters. There's also a validate response that validates the response based on the definition. You can validate examples like that JSON file that I talked about. There's a bunch of ways that you can do the contract testing of this. And this is just one of those ways. This is very useful for early on development, right? You started creating your APIs, and you want to make sure that they're working as they're intended to based on the spec, which is your starting point, right? And in this scenario, and what most of the folks that I've talked to have started shifting towards is the OpenAPI is their source of truth, right? That's where it starts. That's what gets built first, and everything else should fall in line to that definition. And so this is really good for that type of early on testing. So there are a couple different things that you can do. And really quickly, I think I glazed over this earlier, but consumer side or client side contract testing is essentially testing your API in a protected static environment where the tests are run against mocks. And so that's why you see I'm actually running this contract test against my mocked endpoint, where we can isolate the API response and then validate it against a contract for immediate action like this. Like, okay, well, actually, I thought I should be able to pass a string, but I can't. Or my application is passing in a string and it can't, things like that. And so that's very useful to check and validate that way. So this is consumer-side API contract testing. There is the other half of it. It is a producer-side contract testing, which is essentially validating the producer or server side by creating a contract test from the OpenAPI spec file. And so I will show you that in our cloud platform. So I pop back over here. Let me just jump into our API testing. And so here I have our API testing platform. And I'm going to go ahead and actually import my OpenAPI specification file. I'll actually hit just to save time. Okay, I actually already have it imported here, but this is that same endpoint that we saw, or same spec file that we saw earlier, the release notes, user, user ID, echo, so on. I'm going to use the same release notes endpoint, and what I'm going to do before that is a fun little thing where I go ahead and create a tunnel that's going to allow me to call my localhost API from our cloud environment, just because I want to keep it all consistent, and I do want to show you how it works when we're calling the mock. So we'll just give that a second to get started. But while that gets up and running, what I do want to look at is how easily you can actually import your spec file and then run and create that producer side, server side contract test. So I've loaded this up here. I'm going to go ahead and replace the endpoint with my localhost and my port number. And I should be able to select my tunnel here. If I go ahead and hit send, we can see that it's actually still responding to me. And then from here, I can actually really easily generate a contract test. And so there's just a button here. If I did this release notes endpoint only has the definition for a 200. If I had multiple definitions, multiple response codes defined, I could choose which one I want to generate my test for. I'm going to choose the 200, and I call this producer contract. And so click of a button, and now we have our producer side contract test automatically created for us, automatically generated, and variabilized, which is actually really useful when you want to test in multiple environments or when you go from mock to real, right? So right now we're still running on localhost. When I'm ready to run on my real environment, I can just quickly change the variables. But what I do want to show is this assert JSON right here. And this is actually validating that contract that it pulled in automatically from our OpenAPI spec. And so if I actually call this, we can see the contract test being run, and we can see the response from there. Now, this is very useful for testing, like we said, that producer side, the server side, and validating that against your OpenAPI contract. This is sort of a version 1 for us. This is what we call minimal human interaction, right? So it took a couple clicks for me to get imported and generated to this point, but our version 2 that we're really working on is what we're calling passive contract testing, which is you upload your spec, you upload a bunch of things, and then you just let it run. And what we're going to do in the background is automatically validate the contract for you. So think of running a native mobile application test. We're going to be scanning the network traffic. When we find the API, we're going to grab it and automatically validate it against the contract for you. And you'll have results put into a dashboard and all these analytics and everything set up for you. And that's sort of what we're working on next as a, you should be validating your contracts, and it should be really easy, and it shouldn't require much effort at all. Now, I think the benefit from here is that we also have the ability to do functional testing on top of this, right? So I've automatically generated from my OpenAPI spec a producer-side contract test. Well, this is a very useful and valid test, but what if I want to test some functionality things like I want to validate that one of the response points in here, which is my payload dot, and I forget exactly what it's called, so let's double check. contact. So I want to check that this contact is returning an email address. So not only do I want to validate that it's following the schema, or the contract test rather, I do want to check the actual functionality of it. So I want to say, hey, I want to check that this content is returning an email type. And so now I've added a functional assertion on top of my contract test. And if I rerun this, we can actually see that it validates that as well. It does show that it is returning a proper email. It does email validation on it and make sure that it's got all the proper standardized email stuff in there, nothing broken, no special characters or anything like that that might cause problems down the road. And it's really, as cheesy as it sounds, it's really as easy as that, right? You automatically generate these tests, and then you can add a bunch of assertions on top to generate, and you can get as intense as you want with these. You can add in loops and if statements, and you can add variables, and you can string together multiple calls. You can grab pieces of data and pass it to the next endpoint, and just kind of build out your end-to-end type of test right from here in a really simple way. So now we've kind of gone through and added functional testing on top of it. So there's a couple things that I want to point out is now that you've generated all of this, this is sort of now stepping away a little bit from using the spec as a driven part of it, but now that you've done all this work, there's a few things that you can do. One of the things that you can do is easily monitor this scenario. And so I can actually, once I save it and publish it, I can go into here and schedule it. And what that's going to allow me to do is automate this test case now in a really easy way. No CI needed, nothing like that, really simple. I can come into here and just say, schedule contract. And I want to run this every 5 minutes of every hour, of every day, of every month, and just let it go. And what this is going to do is it's going to run consistently in the background and just alert me via email or via a bunch of other platforms that if anything ever went wrong. And so now I have a contract test plus functional test that can just run and alert me immediately so that I can go in and fix things before it spreads, right? Like as developers and as folks that build things, it's sort of crucial that we can resolve or at least find errors as quick as possible. And so if I have something like this that's monitoring for me and I have the ability to know before anybody else, even my end users, find out that things are failing, and then at least it gives me that leg up to say, okay, now I can triage it, I can use all the results and data to say exactly what's happening, try to repair it, and push a fix out. And so that's, I think, crucial. That's not to say that doing automation through CI is not encouraged, right? This is just the easy way, this is the monitoring way. You're generally not going to run a pipeline every 5 minutes. It's a little insane. So this is really good for that purpose, right? So good for monitoring scenarios. And then when you want to do your regression testing, your smoke testing, when you're doing your CI builds, we have ways of triggering that as well, right through a command line tool or an API itself. Most of this platform, which is an API testing platform, is built on APIs. So everything that you're seeing is fully controlled by APIs, and you can do all of that programmatically behind the scenes. You don't even need to log into the UI, which is awesome. But ease of use is what we're going for here. So you have your functional test, your contract test, you have it scheduled, you have it monitored. Well, what if you want to check how this performs under stress, under load? Well, fantastic. Let's go ahead and run a load test against it, right? So let me go ahead and get a load server up and running. And now I have this test that I've already created. It's automatically generated contract test from my OpenAPI. I've added my functional capabilities on top of that. And now I want to see how it works under stress, right? Is my contract going to be validated when it's being hit 1,000 times? Let's find out, right? So if I create a load test here, we can call this producer functional load, whatever, right? And so now I have this ability to create a load test in a really easy way, I think, and a really nice way. And I'm gonna I'm going to set something kind of ridiculous, mostly because it looks nicer, and then I'll run it back with a much lesser one, so we're not sitting here for like 10 minutes watching a load test run. But what I can do is I can set up a ramp-up time. Ramp-up time essentially allows me to say, well, I want to ease into my load test, right? I don't want to just hit it hard. And I can if I want to. I can just set this to 0, and then I can go in and hit it hard. And let's go ahead and do that. And let's run 20 minutes. And then we have something called an intensity map. It's actually pretty cool the way it works. And so I'm going to come back to that after I select how much load I want to run, because it'll make more sense that way. So I'm going to select this load agent here. I have 100 virtual users assigned to this. There really is no limit to how many virtual users you can deploy. It's just the limit is essentially on your hardware, right? How much RAM and CPU do you have? That's how many virtual users you can deploy. And so here I can do something like 25, let's say. I can do any number from 1 to 100, essentially. And then I can choose my intensity map. And the intensity map, what it allows me to do is, and it's a little sort of deceiving, because you would think, okay, well, 100% intensity is 25 virtual users, so 50% intensity is half of that. That's not really how it works. The way it works is how many requests per minute you're hitting it with. You're still going to do 25 virtual users, but how hard are those 25 virtual users going to be hitting your endpoints or your test at that point, right? So for the first 5 minutes, I want to go in pretty hard, and I want to go down to like maybe 50%. And I want to run that for a little bit, but then I'm going to slowly ramp back up and see how it behaves. And so I'm going to do something like that. And then I want to end it out again at 100%. And so what this really is saying is, started off 4 minutes of 100% intensity, which is 25 virtual users hitting it as hard as it can, as fast as it can, and then decrease that by 50%. Essentially what it's doing is it's adding weights between the calls. So it's saying, make your call, run your test, and then wait 50% intensity, maybe wait for 100 milliseconds, 70% maybe wait for 50 milliseconds, whatever the timing is based on how we spread it out. And so you can really get this idea of how it's going to go in phase. Why not? Let's just run this, and then we don't have to see it through to the end. The really cool thing that I really like a lot, actually, is the ability to see it as it's going. And so I'm actually running this, and you can actually see it's starting to go up. Now there's 994 failed tests, and in a second here, it'll probably go up to even more. And I can kind of go and see as it's going through what my load test is doing. And so I'm not having to wait 20 minutes to see if something's wrong. And actually, one of the things that I really like is this new thing that we've added here is this suggestion that says, hey, we're seeing a ton of failures, and you have a 20-minute load test. You might just want to stop it now and figure out what's happening. Maybe not. Maybe you do want to see what happens in the full 20 minutes, but maybe you don't, and maybe there's actually something wrong with your test. And that's actually what this error is saying. It's saying, like, maybe there's just something wrong with your test itself and not the actual API, and maybe you should stop this and try again. But that is not the case in this one. I intentionally have a failure going, and that's why we're seeing that. And so we can probably just stop that. It takes a second to stop there. But the idea being really that it all starts with the OpenAPI spec, right? We started with the contract there. We automatically generated it. I added some assertions from there. Then I built a scheduled monitor test on top of that. Then I built a load test on top of that. And this idea that you can quickly go in and really, from that initial point, spread it out to really full-blown functional and load and performance testing. And all of that includes your contract tests and your functional tests that all started with that spec file that you created, that is your source of truth, that should define exactly how your API works and behaves, and is defined to do that, right? So a couple things that I do want to point out is we do, because we are a cloud-based platform, everything gets put into a nice little dashboard for you. All of your tests, including the contract tests that we ran locally, so we can see this one here. And we can actually see the failed one. If I actually open up this, we have a full report on exactly what happened. That same thing where we provided the string, and it should have been an integer type, as well as some of the other tests that we ran, including the functional test that we ran on the platform as well. And then we have the load testing section where we separate out your load test results as well. And the reason we really separate this out is because it is sort of a separate entity, right? Functional testing, contract testing, a lot of that stuff is one space and one testing type. Load and performance tends to be a different beast, and it's not necessarily grouped together with the others. And so that's how we kind of group it together in that side of things. A couple things, if we go back into the spec here, like I said, you can really get pretty intense with adding these additional functionalities. There's other things that you can do like routing and adding additional layers. So one of the scenarios that I talked about is early on development testing, right? So you've written out your spec, you haven't quite developed the APIs yet, or maybe you do have early on APIs that were created, but you haven't built out all the functionality. One thing that comes to mind is maybe you built out the basic functionality of the API, but you haven't built out the authentication module yet. And so your API right now is just a simple get command where you don't have to authenticate at all. Well, you can actually use some of these XOSCON and some of these other additional elements to add that on top of it. And so what it'll actually do is not on the mocking side of things. So this is completely separate, and this is essentially working like a reverse proxy. And what it'll do is your API, whenever you call it, it'll first hit our server. Our server is going to say, okay, cool, I know what this should do, but actually I see that you want me to add an authentication layer on top of it. Cool, got it. Add the authentication layer, pass it through there, and then let the API go to its normal end route, whatever backend server that you're getting your responses from, and get that response back. And so you can test that out, right? So if it's not quite built out yet, but you want to test it, there's functionality for that. And again, that all still comes from the OpenAPI spec. And so it's really this idea that while the OpenAPI is a definition, while it is a documentation of the API, it's way more than that, right? It can be used for testing purposes. It can be used for development purposes, right? Like I think the title is really, or we're giving a talk tomorrow about spec-driven development, right? So when you're talking about APIs, and the first thing that most people end up doing is creating the spec, is you should really use that to then help you develop not only the API itself, but develop the tests that you're writing against, to develop some layers on top of that, all using this one spec file, which is immensely powerful, right? There's a ton of things that you can do. Like I said, there's the reference points where you can pass it schemas or external values. This is really cool where you can pass an example value, and that's this, this JSON file that I have here. And it's really cool because I can actually just come into here and like change things. And the minute I hit save, it's going to automatically update and reference. So as I'm testing, I'm not constantly having to like restart servers or do anything like that. It's really fast, right? And I can quickly come into here and just change values. And especially if I'm testing things like, well, what happens if this isAdmin value is set to a string and not a Boolean, like it should be? And I can just quickly change things, save it, and then automatically run my tests again within seconds to not have to wait, restart servers, do a deployment, do fixes, do whatever I need to do. And it's as simple as that. It's really just changing things, hitting save, and being done, right? So a lot of powerful things, especially when we talk about development, like building things. Like I know I don't do as much of this anymore, but when I used to do development work, the bane of my existence was stopping what I was doing to change something or fix something, and then coming back to what I was doing, because most of the time I either didn't come back and that just kind of fell to the wayside, or I picked it up days later, or I did come back and I had to backtrack a bunch because I have no idea where I was. And so when I'm in this mode of I need to do a bunch of things, not having to stop to go change something or fix something outside of what I'm doing is hugely powerful. And when you're using the spec file as a reference point, it's really easy to do that, right? I can quickly make changes and just move on and test that way. And so, again, for development purposes, it really allows you to move extremely fast and very like nimbly, if that's a word. Yeah, I think that's what I have. If there's any questions, I'm happy to answer it. There are a few other things that I was gonna bring up, but I wanted to wait till we got through this because it is not sort of related to the OpenAPI specs, but it is questions that I've gotten at our booth outside. So I will address that at some point, but I did want to open it up first if anybody did have a question. Yeah.
Sorry, going back a little bit, when you're doing validation of the spec, are you validating against the vanilla spec, or are you validating against the spec plus your extension? So if you have an example where it was an email,
Yep.
you're validated just checking it's a string and then you have to build a custom test case to check it's an email, or can it sort of pick it up from the faker thing and say check it?
Yeah, so that's a great question. Let me find that part here. Yeah, so here it's actually in my schema component where I'm generating that email. Even though I'm saying it's a type string, it will, part of the contract above. Okay, if I can find it. It's in here somewhere, but part of the contract above also does state that it should be an email type. And actually, the really cool thing is, even if the contract side doesn't catch it, the functional side will catch it. But it should automatically pick up that it is an email type on top of a string type.
Can you show the tests that were generated?
Yeah, sure. Yeah, so there's two types of tests here. So the first test that was created, the automatically generated test here, is going to just create a component that's going to validate the schema essentially from the OpenAPI spec. And so that's going to say, for this endpoint, this is what the response should look like. It should have a text and a contact field. The properties are for text, a string type, for contact string type, and it's actually going to return the email. And that's actually to the first question about, is it going to detect that it's an email on top of a string? Well, that's where this piece comes into play. And so that's the auto-generated part of this. There are a few other ways to auto-generate tests, actually. And that's, again, I think that was one of the things that I was going to bring up, but it is sort of aside from OpenAPI, and so I was going to wait. But since you brought it up, it's a great segue to say, there are a number of ways to actually automatically generate and import your test cases. So actually what I can do is even just make an API request here right into my HTTP client. So I hope this is correct. That's not right. Oh, because it should be a header. Awesome. So I'm just in our HTTP client. I'm actually just manually making an API request here. And this API request has this response below. And I can actually do a generate test again. Same sort of way that we did earlier. But this time it's not being backed by an OpenAPI. And what that's going to do instead is our tool is going to parse through the response and automatically create a bunch of assertions for you. And those assertions are going to check things like the actual responses and if it's following the structure as well as the data types that should be returned. So things like the ID object should always return an integer, or price should always return a float. Image URL returns a valid URL, so we do URL validation against that. Things like the color object should return an array, so it's not going to just be a single object return, but an array of things. And then I'm going to loop through that array as well and validate that. Now this is all going to check just data types and data structures. If you wanted to do actual data testing, so you wanted to say, okay, well I have this API and I want to check that it's returning the right data set, right? So like not just that ID is integer, but ID is 1, 2, 3, and then 4, 5, 6, 7, 8, 9. There are a number of ways to do this. So actually once you've generated this, you can actually convert this into what we call data-driven testing and essentially either do input checking or example validation against things like a CSV file, things like databases, and what you can actually do is call your API pull the data, and then compare it to a data set like a CSV or a database and say, is it actually returning the correct data and not just data type? That's sort of outside of the spec because the specs are all not necessarily purely data-driven. They are just the definition. But yeah, you can even take the contract test and add that layer of, here's where my data is coming from, now validate both for me. And then again, schedule that, monitor that, load test that, all of that stuff. And then a really cool thing is we do have an underlying, so this is really nice and pretty, and it's a GUI. Easy to use, you don't have to learn something nice. But we do have an underlying code view of it. Currently still in XML. We're actually in betas of actually converting that to a YAML format. I'm sure most of you are also kind of shifting towards YAML in most things, and we find that that is a nice standardized way of doing a lot of things. And so we are shifting our underlying code to be YAML-based. And so you could actually write all of these tests locally in an IDE and then put them into Git and do all of that stuff and never actually log into a UI. And so the idea being it is a collaborative tool that anybody can use, right? From the most experienced of developers to the person who doesn't really know how to code but can still write a bunch of tests. And so that collaboration aspect and being able to write the tests in multiple ways. And one of the things that was brought up to me on the table outside is how to tie together your UI tests with your API tests. And one of the things that we've done is actually capturing network, and I talked about this as a future passive contract testing, but we've done a little bit of that now where we've actually given you the ability to, so for anybody that doesn't know, I guess Sauce Labs at its core has done mobile app, mobile web, and cross-browser testing for a long, long time. And that's something that we've fully integrated into, and you can actually pull in HAR traffic from your backend. So like if you run a native app test on a real device, we'll capture the network traffic, put it into a HAR file, and you can actually pull that into the API testing, and it'll actually parse that HAR file, ignore anything that's not an API call, so all those like HTML responses, all of that gets ignored, and it'll just pull in the backend APIs, the request and the response, and then you can take that and generate tests, do load testing, do monitoring, all of that without actually ever knowing how to, one, call the API, and two, even knowing what APIs are being called in the back end of your front ends, right? So sometimes you're testing a front end and you're like, well, I don't really know what the back end APIs are because they're just back end APIs. I'm not calling them explicitly. And so this allows you to pull those in and still test against those at that layer. As someone who has worked with APIs for a long, long time and done some front end and UI stuff as well, if you've done it, you know that it's just easier and nicer to play with APIs than it is the front end sometimes, right? I've had native application tests that I've written take 10, 15, 20 minutes to run, and I have API tests that even the most extravagant and long API tests take a handful of seconds, 5 seconds, 10 seconds, right? Because they're APIs, they're really quick. Response times are in milliseconds. Parsing, it takes no time at all. And so you can really get deeper and, like I said earlier, is get alerted much quicker, right? It's much faster to have a 2-second API test run and alert me that something's wrong than a 10-minute front-end test that tells me something's wrong. And then I have to go figure out what's wrong because the front end looks great. Well, what actually happened is the back-end API broke and sent a bunch of wrong data or didn't send any data, and then your front-end test broke, but it generally looked fine, right? Because the UI is not going to break necessarily unless your API is driving something immense on that side.
So you were talking before about the kind of tests that you can generate automatically, and you were showing also the kind of output assertions that you can make automatically as well. But what about the input data? So imagine an endpoint, an operation that has like a lot of parameters with very specific required input data, maybe with dependencies among the parameters, like if you use this one, you may not use this one, because otherwise you get a 400. Can you actually generate API requests automatically that satisfy all those constraints?
Yeah, it's a good question. So not at the moment. And so a lot of that still requires the human interaction, right? Because There's only so far that our engine can go of knowing how the API should work, even with the contract, even with the OpenAPI spec file. It's kind of hard to tell all of the branches that can possibly go. One of the things that we are doing is we actually have another product of ours that does a bunch of AI ML stuff, and we're actually trying to utilize that engine to do exactly that. So we're trying to take that engine, merge it into our API engine, and say, well, I want you to learn how the API should behave, and then generate a bunch of tests for me for input parameters, all the different validations, knowing that if you call these two parameters together, it's going to fail because they can't go together, stuff like that. And that's actually the next phase of what we're trying to do for auto generation. And I mean, we talked about this outside, is that's the layer that I don't think anybody's really gotten to yet, because it's really difficult, right? It's one of those things that only the person who wrote the API or someone who's works with the API consistently knows what to do. And so we are working towards trying to use some of our AI ML capabilities to actually build that kind of test out. Not quite there yet. I don't even think we have a proper like alpha in place, but I'm still like in that theory R&D phase. Anybody else? Cool. Well, I really appreciate you guys coming in. I'm glad to give you guys back a bunch of times. I know it's been kind of a long day, and a lot of us just got in today, or if not really late last night. So happy to give you back 40 minutes or so. If you do have any questions, I will be out at the booth. We'll be here tomorrow and the day after. Please come find me. I love to talk about APIs and API testing. So stop by, ask questions. Even if it's not around APIs, we do a ton of other things like native mobile, cross-browser, monitoring, error crash reporting, stuff like that, AI ML stuff, any of those topics, happy to entertain conversations around that. Thanks.